So today in class, we saw 3 different properties of logarithms, 3 different ways that we can take some kind of logarithm and manipulate it in a couple different ways. So we are going to see in your 2 videos tonight how we can apply those different properties. But first, a recap of what those properties are. Our first property that we saw in class, the log base b of m times n equals the log base b of m plus the log base b of n. So when we have our multiplication, our log of 2 things multiplied together, we can add the individual logarithms. That's our first property. Our second property was the log base b of m over n equals the log base b of m minus the log base b of n. So when we have the division, the log of 2 things divided, we can subtract the individual logarithms. And then our third property that we saw with our little investigation is the log base b of m to the n power. We can pull that exponent out front, n times the log base b of m. These are 3 logarithm properties that we are going to apply in our videos. So this first example, example 1a, we are going to write as a single logarithm using our logarithm properties. And our first example, let's write the log base 4 of 5x plus the log base 4 of 3x. We want to write as a single logarithm. And I'll do 2 examples here, so leave yourself a little bit of room over on this side. Now, the first thing that I see is that I have one logarithm plus another logarithm. Well, this top property is where I see the 2 individual logarithms added together. I can multiply the individual pieces because I have the same base here. So the log base 4 of 5x times 3x is what I'm going to end up with. Okay, so I take my individual logarithms, they're the same base, they're added together, one log plus another log. I have to multiply what we're taking the log of, multiplying the 5x and the 3x here. Now when I take 5x times 3x, 5 times 3 is 15, x times x is x squared. Log base 4 of 15x squared would be our answer. The second example, we have a little more work we have to do before we get going. So our problem here is 2 times the log base 4 of 6 minus the log base 4 of 9. Now I noticed right away that I have one log minus another, and that makes it look like I need to use the second property. But look at these logarithms here. I don't have any numbers in front. I have a number in front here. So the very first thing that I have to do is get rid of this number in front, which uses our bottom property here. Where I have a number in front times my log, that number in front is really the exponent. So this bottom piece means really the log base 4 of 6 to the second power, which is the log base 4 of 36. And then I'm just going to bring this other part down, minus the log base 4 of 9. Now I don't have any numbers in front. This looks like the middle property now. One logarithm minus another, where I have the same base, we can divide the individual pieces. So that gives me the log base 4 of 36 over 9. Now, one of the cool things about our log properties is when we write as a single logarithm, sometimes we can do some other simplifying that maybe we wouldn't have seen before. Okay, so like right here, 4 to no power gives us 36. 4 to no power gives us 9. But when I combine, 36 over 9 is 4. So this means the log base 4 of 4. And from here, remember what this means. Log base 4 of 4 means 4 to what power gives me 4? It's 1. So 1 is really the final answer after we do all of our simplifying. Okay, so again, sometimes we might not necessarily see right away that we can do some simplifying with our logarithms, but using these properties will help us to simplify in a couple different ways, like we saw in the second piece here.